Hello folks, this lesson is for May 20th. Okay, we're just the second lesson of this unit. What I would like to do first is to think about and try to figure out the ways that we go from each equation to each other type of equation. So from standard form to factored form, we factor, obviously, that was an entire unit. To go from factored form to standard form, we expand, and you might want to say FOIL, because FOIL is a big part of it as well. And let's think about sort of these other ways, the other things we can do here as well. If we had factored form and we wanted vertex form, well, we would find the zeros. We would find the axis of symmetry, and then we would sub in to get the y value of the vertex. And if we had vertex form and we wanted if we had vertex form and we wanted factored form, we would solve for x when y equals 0. And that would give us the zeros, and then we'd write it in factored form because it would have the same a value. So if we have vertex form and we want to go to standard form, we would expand. So you double up the brackets and you FOIL, you multiply through by a, and then you add the k at the end. And if we had standard form and we wanted to go to vertex form, well, we don't really have any way of doing that right now. Currently, we would factor it and come this way. So today what we're going to learn is how we can go directly from standard form to vertex form. And that's all this lesson is. It's a technique that will work to go from standard to vertex, and that's all it is. Okay. So here we go. It's called completing the square, and you're going to see why it's called completing the square in a second. So first, I'm just going to do this example, and you can just watch and take it in. And also, if you get through this and you're like, oh, I need more practice, I want to know more, or whatever, just go into YouTube and type completing the square. You'll find a ton of results. Okay, so step one is we common factor just the number, so just the 2, out of the first two terms. And we get x squared plus 6x. And then, at the end, we have plus 21. Okay, so a bit of a weird step. But I want to show you something. So when we have vertex form, we always have this here. We have x minus something or x plus something squared. So this part right here, if we were to expand that, would be a perfect square trinomial. So what we're going to do is we're going to build in a perfect squared trinomial right in here. Okay? So we have x squared plus 6x, and what can I put after that to make it a perfect squared trinomial? Okay, so what do you think? Well, let's take a look. So y equals 2 x squared plus 6x. So what number can I put beside this to make this so that when it's factored, it's like x plus something, x plus something? Well, we know that if we're going to add the same thing twice, it's going to be 3, right? So what I'm going to do over here is I'm going to take half of 6. And so we know that each x, when it's expanded, is going to be a 3. So this is going to become x plus 3, x plus 3. But what number do I put here to make it so that's going to work? Well, the way that that works is we have to square this number. So check this out. So plus 9. Now, you might be thinking this is some sort of magic, because you can't just add 9 in an equation whenever you want, right? It really changes things. So we're going to subtract 9 at the same time. I'm going to close the brackets now, and then I'm going to write plus 21. And what I want you to understand here is that in these two steps, we factored out a 2. If we expanded, we'd get right back where we were. And then we added 9 and subtracted 9. And again, 9 minus 9 is 0. So we didn't really do anything. It looks different, but it's still equivalent. I'm just highlighting that because that's sort of the important bit. All right, so now we're going to come in here. And we are going to factor the first 3 terms. So if we do that, we get x plus 3 squared. Okay, and this 2 is still attached to this first part. And now we have this negative 9. But it's in the brackets. So that means that that negative 9 needs to be multiplied by this 2. So we get minus 18 plus 21. Okay. And now we get y equals 2, x plus 3 squared. And it looks like plus 3. So I'm in Desmos now, and I graph the original equation, and then I'm going to graph my vertex form, and it's the same. So it worked. Okay, so just to recap, we take the constant out of the first 2 terms. You might have a decimal. Okay, it's possible. And then in the brackets here, whatever value is attached to the x here, I cut it in half and I square it. And that gives me the value that creates a perfect squared trinomial. Now I can't just add a value, so I have to subtract the same value to balance things out. These first 3 terms get factored, and they're still attached to the 2. So that's the 2 with these 3. But the 2 is also attached to this negative 9, so it multiplies. And then we collect our like terms, and we're done. Okay, so here's a whole big thing that goes through all the steps. So you'll notice this one looks a little different, this step here. The sort of tricky step, what I do in this is first I take the 2 and I put it with these, and then I take the 2 and I put it with that as well. And so that's what you see down here. This is, whoa, that's the pink. So this is the blue part, and this is the pink part. I like the way I did it better. This is sort of an old note from a long time ago that sort of keeps popping up. And so I've kept it because it rhymes. It's like a whole poem and stuff. I didn't make it originally. I'm just going to write in the vertex at the end here. I already added this to your note, but I realized I didn't do it here. Okay, so let's do a couple more examples. I think I got 3. And then you'll have some homework to do. So it's a quick lesson today. I'm just making sure that all mine match up with all yours. Perfect. Okay. I would really like you to pause and try this. All right, hopefully you paused and tried it. If you didn't, we take 2 out of the first 2 terms. Now we take negative 6, we divide it by 2. We get negative 3, and then we square it, and we get 9. So y equals 2 x squared minus 6x. Now we always go plus 9 and then minus 9. And the reason is because when you factor a perfect square trinomial, that last term is always going to be added, right? Because if it's x plus 2, the last term will be positive. If it's x minus 2, when you FOIL, the last term will be positive again. Now here's a cool thing. When you first divide this number by 2, that tells you what's going to go in the brackets. So this is going to be x minus 3 squared. And of course, if we need a minus in the middle, it's got to be a minus in here. And then we do 2 times negative 9, so negative 18 plus 7. And we get y equals 2 x minus 3 squared minus 11. Cool. And that's it. Okay, next one. Again, please pause and try. All right, here we go. Take a negative 3 out of the first 2 terms. Now, we do 4 divided by 2, and then we square it. So this is a bit of a weird one because we're adding and subtracting the same number, but 4 is always a bit of a funky one like that. And then we get negative 3, x plus 2, remember I get that from right here, squared. Negative 3 times negative 4 is plus 12 minus 11. Okay, one more to go. Here we go. Y equals, we take the 4 out of the first two terms only, so minus 2x plus 1. 4x squared minus 2x, so negative 2 over 2 is negative 1. Negative 1 squared is 1, so plus 1 minus 1. And then we add 1 at the end. Oh, I almost missed that crucial middle step. 4 times negative 1 is negative 4 plus 1. So y equals 4x minus 1 squared minus 3. All right, now I'm going to go back and check each one just because I sort of rushed through that because I don't want to keep you too long here. All right, so this one is 2x squared minus 12x plus 7, and the vertex of that should be 3, negative 11. Okay, that one checks out. Negative 3x squared minus 12x minus 11. And the vertex for this one should be negative 2 comma 1, and it is. Now we got 4x squared minus 8x plus 1, and based on what I did, the vertex should be 1, negative 3, and that checks out for sure. Okay, folks, I created one more example here because I want to show you what happens when it's not nice and neat. So first, I'm going to take 2 out of the first two terms. So x squared plus 2.5x minus 6. So y equals 2. X squared plus 2.5x. And now I've got to do 2.5 divided by 2, I believe is 1.25. And 1.25 squared is 1.5625. Okay, so that means that we add 1.5625 and we subtract 1.5625 and then minus 6. So this is going to be y equals 2 x plus 1.25 squared, and then we've got to do 1.5625 times 2, 3.125, so minus 3.125 minus 6. So this negative 3.125 was just 2 times this number, and then we get y equals 2 x plus 1.25 squared minus 9.125. So that means that the vertex should be negative 1.25 and negative 9.125. So let's check it out. Desmos. Y equals 2x squared plus 5x minus 6. Okay, so the vertex is negative 1.25, that checks out, and negative 9.125. So that works, right? So basically what I wanted to show you is that this works no matter what. Now in this case, dividing by 2, the fractions turn into nice decimals. If they turn into ugly decimals, this will just get uglier, and you'll have to work with fractions. But most of the ones I'll give you will be nice, easy ones anyway. I just wanted you to see that this works all the time. It just gets a little bit ugly. Okay, so your homework is on the handout, I believe. Okay, and as always, don't feel that you have to do every single question I assign. I know most of you don't. Those of you that do very well, obviously. But feel free to pick and choose if you're finding it's taking too much time. And as always, if you have any questions, reach out. And like I said earlier, you can also, on YouTube, just look up Completing the Square, and you might have someone that's better than me teach you how to do it. And that would be fine. Okay, good luck, folks.